You spend $30 a month on Midjourney or Krea, craft a hyper-specific, technically precise prompt, hit render, and immediately hit a wall. A black box content filter flags your request as a safety violation, burning your credits and halting your workflow. These closed platforms lock away the actual model weights and generation parameters. You are renting access to a proprietary system that refuses to let you tune the very engine you are paying to use. Then comes the subscription math. You end up renting a specialized platform for every single modality because no single service handles everything perfectly. $30 for image generation, another $30 for video, $30 more for dedicated lip-syncing software. You are bleeding nearly $100 a month just to maintain basic parity with current generation capabilities. Your prompt histories, generation seeds, and output assets are physically held hostage on external corporate servers. If the platform shuts down or bans your account, your entire creative pipeline evaporates. Executing a single multimodal project means dragging files between 10 isolated browser tabs. You generate in one UI, upscale in another, animate in a third, fighting quirks at every step. Every proprietary prompt and sensitive reference image you upload is logged, analyzed, and potentially absorbed into future training sets. There is zero true data privacy when your production environment lives entirely inside an external API. Software engineers do not deploy code by pasting it into a third-party black box and hoping the server likes it. We build locally, we test locally, and we control our environments. The logical fix is consolidation. We need a unified local application state that collapses these scattered interfaces into a single, highly controllable dashboard. The current enterprise SaaS model is actively hostile to both rapid prototyping and budget scaling. It maximizes corporate retention by artificially fragmenting your workflow. The countermeasure to this fragmentation is a self-hosted Electron application called Open Generative AI. It bypasses the walled gardens entirely, offering a strictly uncensored, unmetered workspace. The project's community validation is clear. It currently maintains over 8,000 GitHub stars and 1,500 forks, providing a documented codebase for developers looking to exit the subscription model. The repository is engineered to pull the entire disparate landscape of generation models into one cohesive, locally managed dashboard. By ripping the UI away from the corporate backend, it converts a rented service into owned infrastructure. You dictate the routing, the rules, and the outputs. Look at the underlying architecture. The application is built on a Next.js 14 and React 18 monorepo. By compiling that web stack inside an Electron shell, the developers achieve native desktop performance and file system access while utilizing standard React components. The true utility lies in its bifurcated routing layer. Every prompt you submit is aggressively routed down one of two distinct paths: external cloud processing or internal local computation. The local execution path completely cuts the cord. It interfaces directly with an integrated stable diffusion.cpp engine to run models offline, requiring zero internet connection. This means highly sensitive reference images and proprietary prompts never leave your local hardware. You achieve total isolation from corporate telemetry. If Midjourney goes down or an API rate limits your IP, your workflow does not stop. You fail over to your local models and keep generating. You also eliminate the network latency inherent in REST API calls. Generating directly on bare metal means the time between hitting enter and seeing excellence relies solely on your CPU and GPU. This hybrid architecture successfully isolates the user from backend chaos. You get a single, clean interface, whether your render is happening on a server halfway across the world or directly on your own motherboard. When you route upward to the cloud, the scale is massive. The application can query over 200 distinct AI models from a single interface. This volume is achieved by funneling requests through the Mu API router. It acts as an aggregation layer, mapping incoming prompts to the specific API requirements of each external service. You gain immediate access to enterprise-grade video models like Sora and Veo. There is no need to create separate accounts or manage individual subscriptions for each of these proprietary tools. The interface automatically normalizes your prompt syntax. You write one set of instructions and the application translates it perfectly, whether it is talking to a Flux endpoint or a Midjourney server. Iteration velocity spikes. If a prompt fails on one architecture, simply select a different model from a dropdown and run it again in seconds. Compare this against managing 20 different API keys, wrestling with billing cycles across multiple domains, and tracking usage limits on a spreadsheet. Consolidating 200 models into one interface provides a unified infrastructure layer for generative engineering, where you control every endpoint from a single application state. The application organizes this massive model catalog into 4 precise environments: the image, video, lip sync, and workflow studios. The image studio strips away standard constraints. For image-to-image tasks, you can inject up to 14 separate reference images simultaneously to dial in compositional control. Closed platforms typically throttle you at 1 or 2 reference images, severely degrading your ability to enforce structural consistency across complex generations. The Lip Sync Studio handles a completely different modality. It ingests static images or base videos, maps an audio file over them, and outputs fully synchronized talking head videos, executing the entire pipeline within the same UI. For strict pipeline control, the Workflow Studio offers a drag-and-drop, node-based canvas. It achieves the modular logic routing of raw Comfy UI, but implements a much more forgiving user interface that removes the steep learning curve of connecting complex latent tensors. Bringing these distinct modalities into a single, uncensored environment allows an engineer to prototype complex, multi-stage media pipelines without ever leaving the application. But open-source engineering requires confronting hard realities. This architecture has strict friction points. The 200 cloud models are not technically free. To query the MUI router, you must provision and fund your own API keys. You successfully bypass the $30 subscription silos, but you are swapping flat-rate SaaS fees for strictly metered per-token API usage costs. If you bypass the cloud entirely to run local models like Z-Image Turbo or SDXL, the hardware bottleneck is brutal. Attempting offline inference without at least 16 gigabytes of RAM and native Apple Silicon Metal acceleration will throttle your machine to a crawl. Heavy latent rendering will absolutely choke underpowered hardware. Deployment on Linux is also highly volatile. GitHub issue 95 actively documents a severe deployment flaw specific to Ubuntu 24.04 and above. The operating system's AppArmor security module aggressively blocks the Chromium sandbox required by the Electron shell. If you execute the app image without manually patching the sandbox flags, the application will hard crash on launch. Adopting this stack requires high technical literacy. You must have robust local hardware and a high tolerance for debugging undocumented repository issues. If this saved you time, hit subscribe. We review open source tools like this every week, so you're always ahead. Now, if you liked this open source breakdown, you're going to love our review of Comfy UI's exact node routing logic. Which leaves us with a hard question. Are we watching the permanent collapse of the profitable AI wrapper business model? Or will these extreme hardware constraints forever keep self-hosted AI studios locked out of the mainstream?